My presentation is on Niels Bohr's contribution to the atomic theory. Bohr was a Danish physicist who is known for his work with the atomic model, quantum physics, and helping out on the Manhattan Project. Despite the improvements of Rutherford's atomic model over Thomson's model, Rutherford's model still had some major problems with it. One major problem was that it assumed that the Newtonian laws of physics still applied on the atomic level. According to the classical laws of physics, Rutherford's model would result in the negatively charged electrons collapsing into the positively charged nucleus, destroying the atom. Because it is obvious that all the atoms in the universe have not collapsed into nothingness, scientists knew that something was wrong with Rutherford's model. In 1913, Bohr published 3 papers on the atomic model. In them, he proposed a new model for the atom. In his model, he took the paper by Charles Galton Darwin on the role of electrons in the interaction of alpha particles with the nucleus, and used it as a starting point. He then merged the theory of electrons traveling in orbits around the atom's nucleus with the theory that the chemical properties of each element was largely determined by the number of electrons in the outer orbits of the atoms. Planetary models of atoms were not new, but the way Bohr treated the orbit of the electron was. He introduced the idea that an electron could drop from a higher energy orbit to a lower one, in the process emitting a quantum of energy. The electrons can only orbit stably without radiating in certain orbits, called by Bohr the stationary orbits, at a certain discrete set of distances from the nucleus. These orbits are associated with definite energies and are also called energy shells or energy levels. In these orbits, the electron's acceleration does not result in radiation and energy loss as required by classical physics. Though older physicists did not accept Bohr's model, physicists like Rutherford, David Hilbert, Albert Einstein, Max Born, and Arnold Sommerfeld saw it as a major breakthrough. The model's acceptance was entirely due to its ability to explain phenomena which other models could not explain, and to predict results that were quickly verified by other experiments. Today, the Bohr model of the atom is no longer the accepted model, but it is still the best known because it often appears in high school physics and chemistry textbooks. Because it mostly used the hydrogen atom as its basis, Bohr's model broke down when dealing with other elements that had more electrons. Even though his model could only consistently predict results for the hydrogen atom, it got people thinking in a new way about the structure of atoms and eventually led to the creation of new, better-fitting models for the atom. Bohr's atomic model has caused many changes of science over the last century. All experiments investigating atomic structure, like those on anti-hydrogen and other exotic atoms, nuclear power, and recent experiments with the quantum computer, can all be traced back to the advances in atomic theory that Bohr began a century ago. This concludes my chemistry presentation.